detection and how they can benefit your city on the financial side. So obviously if you're losing water, you're losing money. So a quick little bit about us. We've been in business for over 14 years. We have experienced over 16,000 mainline breaks, and we've performed over 700 system surveys. Mainline breaks, typically what we do, as many of you know, in the wintertime things happen to break, water comes up, and instead of punching a hole in the asphalt, guessing where it might be, we actually come out and tell you exactly where it's at. The system surveys, which we'll be going through, is basically going through your entire system and finding the leaks that are currently existing that are not surfacing. And in order to understand system surveys, first you have to understand leak detection. And what leak detection is, and first I'll say this, the nice thing about a leak, not that there's too many nice things you can say about leaks from your side, but they always make noise. They never stop, and because they never stop and they always make noise, there's an algorithm or mathematical equation that they come up with to calculate how fast that water or how fast that noise of the water escaping a pressurized system gets from one point to another. And that's basically the location is equal to the distance times the velocity times the time differential divided by 2. And the way we're able to come up with this information is first we need to know what type of material are we working with. Are we working with ductile, pipe, cast iron, plastic? What's in the ground? What are we dealing with? What size is that pipe? Is it a 3/4 copper line? Is it a 1 inch, a 2 inch? We're dealing with a 4-inch cast, 6, 8, 12, what is it? And then the distance from point A to point B. Now the distance is extremely important because in order to do a correlation properly, again, you're dealing with a mathematical equation. If you put garbage into a mathematical equation, you're going to get garbage back out. So anytime I go out and do a system survey, the guys who are out there know me well enough to have the information and have a very good idea of where things are at. Sometimes I can be a little forward with cities if they just say, well, can't you just find it? Well, no, it doesn't work that way. If you don't know your system, I don't know your system. Basically, we come to your city blind. We don't know where your main lines are. We don't know where your valves are. We don't know where your hydrant leads are. So if you don't know your system, then you're going to end up with a bad locate. So in this picture here, you can see transmitter 1, transmitter 2. You've got water coming up. Let's say it's in the street by a fire hydrant. And so what we do is we connect our transmitters to either, it could be right to the valve nut itself, could be to a hydrant, could be to a valve key. One on either side of where we believe the leak is at. And then what the transmitters do is they basically just send a picture of the sound wave that they're hearing back to the correlator every 0.8 seconds. And what the correlator does is it takes those pictures, overlaps them, looks for that one common denominator because, as we said before, the leaks never stop, so therefore you always have that one constant noise going. And it looks for that for both transmitters. And it knows how fast sound travels through this pipe of certain size, of certain material. And it can calculate, like here we have an example of 400 feet from valve to valve. And what the correlator would tell us is that the break is actually located 100 feet from transmitter 2. We would then use our measuring tools and measure out 100 feet, put our necks on the ground. So there you go. Some examples of how acoustic leak detection works really well. Now I've been to many cities around the upper Midwest, and I've gotten a lot of excuses for people on why they don't use this, why they don't do system surveys. I hear things like, our leaks always come straight up. We've got forgiving soils. We don't have mainline breaks. We don't have leaks in our system. Well, hopefully none of you believe any of that because none of it is true. Sometimes you'll have a break that happens to, and you're very lucky when it does. But this is an example here in Golden Valley. We had water boiling out of a 6-inch main break down here by the back of the truck, and actually 75 feet away in front of the hose where the mainline break is actually at. Another example here in New Brighton. This is down the center of a street here. I believe this is a county road. They have a 12-inch main coming down here. And where the water is boiling out, again, 125 feet away from that is actually where the mainline break is. they were actually getting ready to dig in this area. They're getting the hose set up and getting ready to hammer this open. Well, we got some funny looks when we told them, no, it's actually up the hill. One thing about water is it will always take the path of least resistance, and gravity likes to help it along. So if you're on a hill, a lot of times it'll push that water down. If you've recently overlaid a street, as you know, that asphalt can be pretty tight to those curb lines. Just because it's popping out there doesn't mean that's where it's at. Has anyone here ever, I'll get to you in a second. Has anyone here ever chased a leak before? You know how expensive that can be, punching multiple holes. You know, that's one thing about leak detection, is that we have over a 95% success rate in putting that leak in the hole every time. You had a question?
Yeah, I was just going to make an interesting statement. We had a community that took us forever to find a leak, and they were losing a lot of water, and then we ultimately found out that their leak was dropping into a 12-inch tile line, which was going onto a crib, so we were never going to find it for, it took a longer time to find it, fix that. So.
Oh, absolutely. And the entire time that thing is running, they're paying for it.
Yes.
Yes. The longer you let that run, the more money and revenue that you are losing. I'll be getting to that in just a second, because a lot of people will look at that and see a lot of water. To me, I look at that and I see dollar signs coming out of your street. Now again, acoustic leak detection is great, but the most important part of acoustic leak detection is you. It's not the equipment we have, it's not the knowledge that we have, it's the knowledge that you have. Now, there's many people that are actually looking at retiring down the line, and I bring this up every time I give a presentation. There's so much information that every one of you has in this room. If it's not written down somewhere, that information gets lost. And then whoever is coming up in behind you doesn't have the information that you have, doesn't have the knowledge of the city that you have. But if you don't put that down somewhere to share with them, that information is lost forever. When that information is lost, that's dollars that your city will lose down the line when that issue comes up again. Things as simple as witching. You look at this hydrant right here. If the snow is actually covering this, you would assume that the hydrant is connected to the street in front of it. Well, with this valve, once they actually pulled the plans out, we saw that this hydrant lead is actually connected to the adjacent street, which added over 60 feet to the locate. Now, as you saw in the mathematical equation before, everything is divided in half. If there's 60 feet that we're missing, that means the locate itself is going to be 30 feet off. And then we're getting a phone call going, well, you're off. What's going on? Well, if we don't know where your leads go, let's shut that up now. We can't give you a good locate. Again, garbage in, garbage out. It's not magic, it's very straightforward. Now, water system surveys. Every year we go through and try to help cities lower their overall water loss percentage. A lot of people will say you're unaccounted for water. I call it your non-revenue water. Because why are you pumping water in the first place? To sell it, to provide a service. For water use, water distribution, and also for sanitary purposes. So what is water? Many people say that water is an asset. Well, eventually it becomes an asset. And an asset is anything of value that can be converted into cash. Assets are owned by individuals, businesses, and governments. What water actually is, it's no different than a tree, iron ore, copper, coffee, a commodity, a raw material or primary agricultural product that can be bought and sold, such as copper or coffee, a marketable item produced to satisfy wants and needs. Again, there's a lot of times I'll go in and talk to cities, and they'll tell me that, well, they're a nonprofit. We don't have to make money. We don't have to, do the things that a business does. Well, fine. You're a nonprofit, but you're still a business, whether you believe it or not. You have a commodity, you have something that you sell, and you rely on that in order to keep yourself functioning, to pay for your salaries, to pay for your equipment, to pay for your fuel power, all of those things. So your water is your most important asset once it's in your system. If you disagree with me on that, that's fine. I have no problem with that. It's okay. Something I want to bring up. Now, the PSC from Wisconsin is the Public Service Commission in Wisconsin. They actually did a 3-year study on what cities spend on just fuel, power, and chemicals to do nothing more than pump and lose water. A 3-year study. The Public Service Commission from Wisconsin, they regulate all of the rates, water rates, sewer rates, gas, everything. It all has to go through them before anything can be raised as far as rates go. This is actually a 900-page report that they gave me, but we're only going to look at a few pages. Now here, you can see the city of Hudson, Wisconsin. Now these numbers are so big that actually 3 zeros were left off the backside of them, just so you know. So up here, the 742 is actually 742 million. The pump not sold amount was over 93 million. The authorized unmetered usage, once subtracted from that, was 19 million, giving you your overall water loss of over 74 million. Fuel and power and chemical costs gave them an average of 23 cents per 1,000 gallons. But still, sitting at roughly a 13% water loss, they're spending over $17,000 a year just to pump and lose water. That doesn't even touch the revenue side of it. Something else I'd like to bring up with this is we have this affliction with looking at percentages. We have this 10% number stuck in our heads. Got to be 10%. DNR says 10%, 10%, 10%. Well, what's an easier sale? 10% or what 10% actually means? What I mean by that, you look at the city of Green Bay. They're under 6%. But that 6% equates to over 355 million gallons of water. Obviously, the larger the city is, the more water you're going to pump. The more water you pump, those smaller percentages make that number get bigger and bigger. But here they're under 6%, and they're still spending over $50,000 a year to just simply pump and lose water. The city of Greendale, they're sitting at around 20%, but they purchase all of their water, but they're spending over $62,000 a year to do that. These water losses that we have, it's not just a percentage you have to meet. It's your revenue that you are losing. You're paying to put that water in your system. It's there so that you can get paid for from your customers. The village of Howard is actually a city that purchases all of its water from Green Bay. And they're kind of an interesting city here. They're at just under 9%. But that 9% equates to only 50 million gallons. But that 50 million gallons of loss equates to over $216,000 because they purchase all their water. I don't know how many cities in here purchase water from other communities, but if you're purchasing water, it can be a very expensive thing if your loss percentage is even in the single digits. And not until 2010, when they got up to over 20%, did they say, well, we're going to start looking at this and figure out why we're losing all this water. Of course, at that time, they're losing over they're spending over $459,000 to lose that water. And then the flags went up. Now we're going to check into it. I don't agree with the way that, unfortunately, a lot of people think. And I know I've given this presentation before, and a lot of times I feel as though I'm preaching to the choir. You know, there's a lot of battles that I know that you as operators and superintendents have to go up against when you have, city councils to go up against that are refusing to spend money. Why do we do a system survey? How much does it cost? $2,000? Are you kidding me? But yet they'll spend tens of thousands or hundreds of thousands of dollars because they don't see it. A lot of times they're walking through with blinders on. We're just doing this. We're not going to do anything else. We're just, don't spend money, don't spend money. Well, a system survey, all it is an investment in your own water system. To find those issues that aren't popping up. Because in 14 years that we have been in business, and with the hundreds of surveys that we have done, we have never gone to a single city and not found an issue in 14 years. And many of these cities that we do are cities that do surveys every single year. And every single year, we continue to find issues. But yet I still get into, well, I wouldn't call them arguments. Heated discussions maybe with some directors and whatnot. I actually had a discussion with the director of Bismarck, North Dakota. And they're at 8% water loss. Well, they pump upwards of 4 billion gallons a year. So that puts them at roughly 250 million gallons a year that they're losing. And I said, well, doesn't that seem like a lot to you? He says, well, Minnesota, 10% is good for you guys. I think we're doing great. Okay? And besides, we have 3,500 hydrants that we flush every single year. So I did some math for him. I said, all right, let's do this. When you flush your hydrants, is that the largest usage of unmetered water that your city probably has? Yeah, that's a fair statement. So I said, all right, let's do this. Let's say every single hydrant, you flush 11,000 gallons out of that. For those of you who flush hydrants, if you know anything about how much comes out of there, that's a high-end number. And so I did the math for him, and it came up to 38 million gallons. I said, okay, there's 38 million accounted for. Where's the other 200 plus million gallons of water going that you're paying for to lose? Well, we've got plenty of water in this state. We don't need to worry about that. Unfortunately, there's a lot of mindsets that some people have. They just want to put the blinders on and keep status quo. Let's keep it the way it is. Why should I do anything more? Why should I look for issues if I don't see issues? Because it's costing your city money. The longer you let it sit, the more money it's going to cost you to fix it once it finally does surface. If there's anything we know about leaks, they never get smaller. Anything, they get bigger and bigger. City of Milwaukee, roughly 13%, but they pump over 37 billion gallons of water a year. 37 billion gallons. 13% means they're losing over 4.4 billion gallons, costing them upwards of $970,000 a year. And even for small cities, small cities don't have that many paying customers. So therefore, your percentages and your non-revenue water that you're allowing to escape is more vital than anything. There's a lot of cities that I've gone to, they're like, our water loss is 30%, it's 35%. But we don't have any money to do a survey, so. Well, you do have money to do a survey. The problem is, you're more interested in spending it on the water and the water, the chemicals, the fuel, the power. You'd rather put it into that and lose it rather than be proactive and find the issues and stop the pumpages from happening and being lost. We're going to look at some case studies that we have done. Now, I've actually been with Water Conservation Services now since 2011. I actually used to compete against Water Conservation Services. The situation that I was in didn't work out so well, so I came here. And I've been doing these presentations now since 2011. And fortunately, a lot of people have understood it. looked at it from a different light and had interest in it. Last year alone, our company listened to upwards of 70,000 hydrants in Minnesota and Wisconsin alone. 70,000 hydrants, that's a lot of hydrants. People wonder exactly how it is that well, how do you know what a leak sounds like? Well, when you listen to 70,000 hydrants a year, you kind of get an ear for it. I use an example where I was doing a system survey for the city of St. Louis Park. And there's a hydrant not more than 100 feet away from Highway 169, which is extremely busy in the morning. I was there, it was between 7:30 and 8 o'clock, so there's full rush hour traffic going. And if you ever stood and just listened to the way the traffic sounds, there's a rise and fall as every car goes by. And when you're listening to a hydrant, everything is amplified 10 to 20 times. But as I'm listening to it, you can obviously hear the rush hour traffic going by, but there's something in the background that's just sitting there. It's just this, it almost sounds like static. And I was even kind of surprised that I actually heard it, but it ended up being a service leak that was 350 feet up the road. Again, the nice thing about leaks is that they make noise. And because they make noise, we can find them. The city of Buell, I met John Marcus. He's the director for the city of Buell last year, actually at a rural water school up in Wabac. You'd never heard of leak detection before. I still run into cities that have never even heard of leak detection before. And it's been around since the mid-'80s. Technology's gotten a lot better. But they knew they had an issue going on. And so he said, well, get us a number, give me a price. And so I gave him a price. What we would do to come up there and do a system survey for them. They have 65 hydrants. They're a city of 1,000 people. Went up there, it took me less than a day to do the survey, and found a 4-inch mainline break that was dumping right into their sanitary sewer. And they knew it was going into their sanitary sewer. And I said, John, would you mind at the end of the year, when you're doing your water reports, just put some numbers together for me, let me know, give me an idea of, what is this now saving your city? I was actually back up on the Iron Range, was less than a month later for another city doing another survey. I stopped in, and John, how's it going? I said, well, Kirk, you've made a lot of friends in this city. And I'm going to be telling a lot of people about you. I said, why is that? He said, I've been here for 27 years, and our daily pumpage has never been this low. In the 27 years that he's been there. One 4-inch main break. How long has that main break been going on? If you're in a city that has never had a system survey done, how do you even know what your daily pumpage should even be? If you don't have a baseline to start with, all you have is an assumption of what your daily pumpage should be. So their pumpage went from, was around 90,000 gallons a day, what was it, 94,000 gallons a day down to around 70,000 gallons a day, saving them 9 million gallons a year. So John put some numbers together for me. I actually just got these last week. Their annual cost to produce water was almost $30,000 for a city of only 1,000 people. Their sanitary costs, because they knew this was escaping into their sanitary sewer, was costing them $20,000 a year to treat that water that was escaping. And on the revenue side, they were losing around $30,000 in revenue on the water side and around $19,000 on the sanitary side. So on a yearly basis, when you put all the numbers together, this little town of 1,000 people was losing upwards of $100,000 a year on one break. City of Alexandria. We did a system survey for them for the very first time last year. And they actually gave me a report on just their revenue side. And what we found for them was we found three service leaks and 10 hydrant leaks. On just the revenue side alone, they estimated they were losing $20,000 a month just in revenue on the water that was escaping from those leaks. And those are small leaks, just service lines, hydrants. I mean, how many cities in here flush a hydrant every year? Sometimes twice a year. I mean, do you listen to every single hydrant after you shut it down to make sure it's not leaking? Because as we know, when something's leaking, it doesn't just stop. It gets bigger. City of St. Louis Park, as I said earlier, we do this city every single year. There's 1,700 hydrants in this city every single year. And every single year we go there, we find routines for issues. Mainline breaks, service leaks, hydrant leaks, and just on the production side, we save them annually around $80,000. Just on the production side. Not even bringing in the revenue. If you brought in the revenue, you could probably, that easily becomes a six-figure number very quickly. The city of Wayzata, another very good story. Jim Ebensteiner is the superintendent of the city. He started with Wayzata in 1987. In 1987, their daily pumpage was around the mid 400,000s per year. Never had a system survey done before. And the city obviously grew. Buildings got demolished, new ones got built. Housing market did what it did, and lots of houses got put in. So their pumpage was going up. Went up into the mid to upper 600,000s by the year 2000, 2010, in that area. So in 2010, I talked with Jim and he said, you know what, we've never done it, let's do it, what the heck. So we went in there, did a system survey for him in October 2010, and we found these 6 issues. 2 mainline breaks, 3 service leaks, and a hydrant leak. Interestingly enough, there was a creek that ran into Lake Minnetonka that had always been there, until they fixed those mainline breaks. That creek dried up. There was an apartment owner who was scratching his head wondering what the hell the city did. What'd you do to my creek? Well, we fixed it. We fixed your creek. But I did the same thing with, I asked Jim the same thing that I asked Buell to do. Once at the end of the year, let me know what your daily pumpage ended up being. And actually, at this conference last year, Jim brought me his information. He said, Kirk, I had to check my numbers 3 times to make sure that I was actually doing it right. Their daily pumpage dropped 211,000 gallons a day after fixing these 6 issues. Their pumpage went back to what it was in the late 80s. So imagine that. 20 years of pumping. A low-end figure that we put on it of around $60,000. Jim estimated the production side to be upwards into the mid-70s. And that doesn't include the revenue that they were losing as well. And if you have a leak that's going into your sanitary, then you've got your production loss, you've got your sanitary costs, and you have your revenue costs that you're out. That's money you don't get back. New Brighton, there's another city that does a system survey every single year. Every year we go through, every year we find something. Here it costs them $3,300 for an annual savings around $60,000 just on the production side. This is an example I like to bring up at New Brighton, one of the mainline breaks. All of our mainline breaks surface. We don't need to do a system survey. If it breaks, it comes to the surface. We have forgiving soils. I love that one. We have sand. Well, if you know anything about sand, it's very porous. It likes to eat water. And not until that leak gets big enough is it actually going to come up through the sand and through your street. So here's one they're all clay soil. We've got a 6-inch main line running behind the curb, and right in this guy's concrete driveway. is a 6-inch main break, boiling away, but not surfacing. Where it was going, they didn't know. It wasn't going into the sanitary, it wasn't going into their storm. Water will always take the path of least resistance. You know, it's buried 6-8 feet down. Out of sight, out of mind, there's no way to run a utility. Just because you don't see it doesn't mean the issues aren't there. And if you don't go looking for the issues, then you're allowing your city to be a reactive city. And that costs your city money. And that's money out of your budget. I don't know too many cities right now that are throwing cash in here because their budgets are just so full. City of Bemidji, we do half of their system every single year. They're an all sand city. Every year we find issues for them. Estimated savings around $30,000 a year. This is one of them. It originally was marked as a main break. Turned out that it was a service leak. Anyone here have a house that maybe went vacant? Maybe it burned down, maybe it got demolished and just the vacant lot is there? How do they terminate the service? There are many cities that we go to that we have this exact thing happen. We correlate the area, we get a nice spike that says, hey, there's a main break right here. Well, we don't believe it to be a main break until we listen to every curb stop that's in the area where the correlator says that leak is at. This one, apparently they weren't able to find the curb stop. They dug it, ended up finding a vacant cork running out to a vacant lot. Turned the cork off, leak stopped. Not quite sure how long I've been running. All sugar sand, odds are that would probably not surface. Okay.
I have a question for you.
Yes.
Some of, I don't know how many cities have this problem, but we just redid a street this year where we put new water main in. We had 2 maps for this, where we thought the water main was.
Okay. Yeah.
We had 2 maps showing the water mains running. One shows it's running on the east side of the street, one shows it's on the west side of the street. They give 2 different diameters of pipe.
Yeah.
We're not even sure what the pipe was.
Okay.
But when we got done with the job replacing the line,
Yeah.
it wasn't in either one of the spots. So you come in, say I've got a leak, you come in, we've got completely wrong information like that. What can you do? How do you go about doing a system test on this thing?
Well, what and I'm assuming they weren't able to trace it or anything. Was it traceable or not?
No.
No? Okay. Well, basically what we would do is we would do everything we possibly could. We'd correlate it, giving both situations. We'd correlate it on one side, let's say the measurement is, what is it on the west side, what is it on the east side. We'd give you all the information we possibly could, because you're only giving us as much information as you can give us. And then we would try to listen to everything that's in the area, your curb boxes, your main lines, your hydrants and all that. We would do what we could for you.
When you do a systems check in them old parts of town where the information's a little scattered,
Yeah.
how critical is that information going to be for you? Just looking. I mean, really, I know it's a pretty broad question.
No, it's a very legitimate one too, because there's a lot of the emergency breaks that we go to when they've got water coming out. A lot of times we'll go in and they'll say, well, I think the main line does this. I think I think it's a 6-inch. I think it's an 8-inch. We've been doing this long enough, and Tony who owns the company actually used to be an engineer. I was in the construction industry for quite some time and worked with infrastructure and have a very good idea and understanding of how typically they lay pipe down. And we try to think like a contractor would think, when they're putting this pipe down, because as we all know, contractors don't always do the right thing. Sometimes you do what's easiest. Instead of putting a 22 on, maybe they'll just kind of bend the pipe around that corner. Jockey it a little bit. So we take all those things into consideration when we're doing this. Battery's kind of bad, yeah, okay. And really, since it's all based on mathematics, we'll get you as close to whatever we can with the information we can. You know, I mean, there's many things in this industry. In the 14 years that I know that Tony's been doing it, I've been in this industry since 2009. A year has not gone by that we have not learned something new. You know, because every city is different. Everything, no infrastructure is exactly the same. You know. But again, we will do everything we possibly can to get you the information you need to get you on top of that leak.
Okay.
You know, we don't leave people hanging high and dry. We consider ourselves perfectionists, I guess, and we hate to be wrong. And so that's why we ask a lot of questions. It actually upsets some people because of how many questions we ask sometimes. What do you get my as-bills for? Well, I need to know where your main line's at. I've had this happen quite a few times on emergency brakes. I had one happen in Plymouth where they told me, well, it's a valve-to-valve shot here, so I think that's what it is, so just do that. And then they're looking at me wondering, well, why is there a 30-foot hole in the street? Well, because you told me from this valve to that valve is how it ran. And it actually ran up on the right side of the street, and there was a 30-foot gap from the valve to the T. So there's a massive amount of footage that we were missing. So once I show the director that, he's like, oh, okay, I understand. We didn't give you the right information. And they understand how this works. You know, again, it's not magic, it's math. Can I answer your question?
Yep.
Okay.
Got one more for you.
Yes.
Got a pipe in town that we know there's a valve on it that's closed.
Uh-huh.
Can't find the valve.
Okay.
Is there any way of locating them?
Try a metal detector?
Oh, yeah.
Okay. Not unless the valve is leaking.
Okay.
I have had cities want to use this to try to find where a corp is because they don't know where the curb box is, they know where to start. And what we can do is if we go up to the house, open up the outside spigot, so you got a 3/4 line wide open. That makes enough noise and enough noise on the main line for that draw will actually, our equipment doesn't know the difference. It's just looking for that one constant noise. And I've actually located some odd situations in cities that way too, where they think it's a main line break. I had one in Chaska where it was on a Saturday, water's coming up out of the street in the, what would be the southeast corner of the street. They figured it was a 4-inch main break. So they had us come out anyway and just check it out, correlate it quick. Well, where I put them was actually 35 feet further to the south, back by a hydrant leak. They're like, that doesn't seem quite right. Are you sure? All right. So I shot it again. Tried a different setup. I got the same area. Listen to the hydrant, and the hydrant's just wailing away. It's extremely loud. So they go, all right, we'll dig it. They start digging. All of a sudden, they hook a service line. Pop! Water starts coming up. Shut it down, shut it down. Turns out, what it was actually a service leak. When the contractor came in, for some reason, 30 feet back from the intersection, they had two corps that went north through the intersection to feed the houses on the northwest and northeast corner of the intersection. So there was over 300 to 400 feet of service line that they ran. And the superintendent looked at their GPS guy and he's like, well, put that on your map. That's probably a good one to have. They had no idea that it was there, you know. And obviously that information wasn't shared with the water department. Now, that's something that an engineer or, you know, whoever's in charge of that project when it happened in the first place should have marked that. That's pretty important. Any other questions?
Yeah.
Yes, yeah.
How accurate can you be when you've got a leak and right next to it there's a 8-inch clay field tile going on top? My leak was going right into this field tile.
Well, if we can focus just on that main line, Typically, we can be within a couple of feet of it if the information is accurate. Now, again, we have over a 95% success rate with putting any leak inside of the standard size hole.
And it never came to the surface. The
Yeah.
only reason we knew about it is 2 businesses were in this alley were out of water.
Okay. Yeah, now as long as we can get, if you have a suspicion that you have a leak on a main line in an area, first thing we would do when we're doing a system survey, we would go through and we listen to every single hydrant that you have on your system. We hear noise on a hydrant, we circle it, we go on. We go and finish the rest of it. Get the bulk of the work out of the way after listening to these hydrants. We go back to the ones that we heard noise on to make sure that noise is still persistent. If that noise is persistent, we know it wasn't usage. And then we get out our correlators and then we figure out what exactly is it. Is it a service leak? Is it a main break? Is it a hydrant leak? Is it a valve leak?
Does water flowing through that tile throw you off at all?
Typically no. No. Unless, I have run into situations where we've had 2 service lines running in parallel. One of them was leaking and spraying against the other one, and actually did the correlation on the other side, and actually was able to pick it up on both of them. Because, again, the machine doesn't know any different. It's just listening for that one constant noise that both terminals hear. So we can pick things up if it is a constant noise on the main line. Again, we're basing everything that we have on the information that we're given and what we assume is happening down underneath. But of course, as you all know, it's not always exactly what the engineering prints may show. The City of Big Lake. One thing that we do know about non-revenue water, it's either being lost or unaccounted for because of a metering issue or it's leakage. Those are the only 2 things about it that could possibly have it be unaccounted for water or non-revenue water. City of Big Lake, they actually were losing 100,000 gallons a year. They went through all their metering, took them over a year to do that, continued to lose 100 million gallons a year. They're in all sugar sand city. Then they finally said, well, why don't we have you guys come out and take a look? Well, we definitely found where your water was going. 3 mainline breaks, a bunch of service leaks, hydrant leaks. For some reason, they had a 1-inch wide open line that had been leaking since 2006 that they knew about, but never did anything about. It's a lot of water. City of Delano, another city that we did for the first time. We went out there, found a service leak, 3 hydrant leaks. They were kind enough to share this information with us on the annual cost us on the production side. They were losing around $3,800 a year. They figured in 7 months, after they fixed these issues, they would have already paid for the survey. And then I took it upon myself to look at, well, how much are you charging for 1,000 gallons? And so on the revenue side, they were losing over $31,000 on revenue, just from a service leak and 3 hydrant leaks. Combined total, almost $35,000 a year on the production and revenue side. River Falls, another city that right on the river. They knew they had issues going on, called us up and said, hey, can you help us out? Went out there and found 4 mainline breaks that weren't surfacing. And 2 service leaks. Just on the production side, saved them over $100,000, over $120,000 just on the production side. And the thing I find very interesting is that it's, to do a system survey, you're looking at pennies. Typically, it's around 1 penny per lineal foot of mainline to do a system survey. And even when superintendents and operators have this information and bring that to their councils, the councils just won't listen to it. Again, that's why sometimes I feel like I'm preaching to the choir. You guys know this stuff. There's so many variables that you have to deal with on a daily basis with your distribution system. You know, how can you cover all of them? Nice thing about a system survey, you cover all your leaks in 1 year. You know, and it's not something you have to do every year. I would like it if you did it every year. But really, we have cities that'll do half a system, quarter of a system every year, keep it in rotation and just use it as part of their maintenance package. And work it into their budget for that, because they know every single year we're going to find issues for them, and every single year it'll pay itself out. Again, I've heard many a time, all of our leaks come to the surface. A lot of times in the wintertime, we end up having to do what's called an emergency system survey, where the city's water towers are dropping out of sight, but no water is coming out. City of Red Wing, Columbia Heights are both losing $250,000 a day. We went down there, surveyed their towns quickly. Red Wing had 2 mainline breaks that weren't coming up. Columbia Heights had 3. City of Robbinsdale was losing 1 million gallons a day, and it did not surface. It was surprising. They were looking for a geyser coming up out of the street. What actually happened, it was a 10-inch main line that when it blew, it actually blew a hole into a storm sewer. And that storm sewer's outlets were far enough away where the lakes that it feeds into looked like just a little trickle, because the pipes got so big at the end. And of course, at 1 million gallons a day, you would think, whoo, she should be flying. I put some information together over the past 3 years of what we have accomplished. 2010 to 2012, we did 137 total surveys in the state of Minnesota, some in Wisconsin as well. 85 of those were cities that do them on an annual basis. 62%. Keep that in mind with these numbers. 62% do this on an annual basis. 457 hydrant leaks, 258 service leaks, 80 mainline breaks. Low-end water totals, 2 to 6 billion gallons of water. These cities were pumping out. On both the production and revenue side, you're looking at, on the production side, $2 to $6 million to lose that water. Just on the revenue side, $5 to $16 million. That's just on a national average of $2.67 per thousand on a revenue side. Annually, I mean, you're looking at $10 to $22 million on just 137 cities, where 85 of them, or 62%, do them on an annual basis. We've done less than 14% of the state. There are over 700 distribution systems on the public side. That doesn't include the 200 plus on the private side. In 2011, the state of Minnesota pumped over 186 billion gallons of water and lost over 25 billion gallons. Now, to give that some thought, I know in the billions is quite a bit. If you took every single person in the state of Minnesota, man, woman, and child, gave them a 1-gallon jug, they would go to their tap 13 times a day for a year. Every one of them. Fill it up and dump it out. And you would not be reimbursed for a cent. 25 billion gallons unaccounted for in the state. We're wasting a lot of money. It's a very easy way to recover some of that. A big reason why I do these presentations, 60 to 80 years ago, you never would even seen this. Never would even talked about it. The idea that our water levels are dropping, the aquifers are getting lower. 60, 80 years ago, there wasn't a single state in the United States that had water shortages. In October 2012, a report came out. 36 states in the United States currently have water shortages. They do not have enough water in their state for both economic and agricultural purposes. 36. We are very blessed to be in this state because we have a lot of water. But the one thing about our water is that all of it flows out of the state. We're pumping it out of the ground and then dumping it into the river. The river goes down to the Gulf of Mexico. Our water demands will never go down. Our population will never decrease. The agricultural side of it, you can see, is 40% of where our water goes. Well, 70% of this of our world is covered in water. Less than 1% of it is actually fresh water. And over 7 billion of us have to use it. That doesn't include the animals, the crops, none of that. Yet we take it for granted because we have so much water out there, it's just something we don't think about. Yet the repercussions are quickly catching up. And I really don't, I do this presentation not just to bring the information to you, but I'm hoping to change the way we look at things. You know, I want things to slowly get better. The more information I can bring to you, the more information you have, the more armed you are to go in and do what's best for your city. I don't know where my kids are going to be living. I don't know where my grandkids are going to be living. But I don't want them to have to worry about rationing water. Because we don't want to take the time, we don't want to fight the fight to pump it unnecessarily and send it down the river. These stress aquifers are just growing in size. I don't know if any of you heard about White Bear Lake and how quickly that's going down. All of our groundwater is connected to the rivers. It's all connected. You know, we keep pulling out. Mother Nature will never work on our timetable. As badly as we'd like it to happen, it's not going to happen. So we need to start being more responsible, in my eyes, for the water that we use and pump unnecessarily. So my challenge to you, if you've never had a system survey done before, or you want to, you know, if you're having issues with your government bodies, to do these sorts of things. Look at your non-revenue water. Don't look at the percent. Again, the percent is an easy thing to sell. Look at the gallons. How many gallons are you pumping unnecessarily? And calculate the true cost of what it costs you to produce 1,000 gallons of water. What are your chemical costs? What are your power costs? Anything that is reliant upon your water for funding should be put into that true cost of that. Calculate what that is for 1,000 gallons. And then put that together with your revenue. Both your production and your revenue. Put that with your non-revenue water total and bring that number to your council. If you combine the two, you'd be surprised how quickly that number gets really big, really fast. And the easiest thing is just care. Don't ignore it. Don't have the blinders on, you know. Leave your city in better condition than when you found it. Nobody wants that. But water leaks are very corrosive, and you know, that happens every year. Well, I really appreciate your time. I really appreciate your attention. I really appreciate you sticking around for the last presentation of the day. Does anybody have any questions about anything?